So now that we have our formulas actually, four of them, for the equation of a parabola, we're going to take a look and see how we can use this formula. So in this lecture, we're going to go in the direction of we're going to start with an equation and see what information we can get from it. For example, we've got an equation here for us to start with, a pretty relatively straightforward one. There is no x term, right? So this looks like the ones we did in the very first lecture where we had the vertex at the origin. What the question is asking here is for us to describe the parabola. You'll also see sometimes the word analyze used. And all that really means is just tell me everything about it. Tell me where the vertex is, where the focus and directrix are. Tell me which direction it opens, right? And because I've got some graph paper over here, I'm also going to go ahead and sketch a graph of this thing. Okay, so like I said, there is no x term. So the vertex is going to be the origin. And if you really want to see that, I could rewrite this x minus 0 squared equals negative 20 times y minus 0. And now, yeah, you can see that h and k are 0 for this equation. All right, so that's my vertex. The vertex is at the origin. I'm going to go ahead and sketch that in here, right? Put that point in. Now, the next thing I need to do, I need to find the value of a. Remember, the general equation here is x squared equals negative 4ay. And if you compare that to the equation we're given, the negative 4a has to equal negative 20, which means a equals 5. Now remember what a means. A is the distance between the vertex and the directrix in one direction, and the vertex and the focus in the other direction. Now, because our parabola opens down, the directrix has to be above the vertex, and specifically it's going to be 5 units above. So the directrix will be right here, and the equation of this line is y equals 5. So there's my directrix. Finally, where is the focus of this thing? Well, the focus is, it's kind of the same process as the directrix, but it's in the other direction. So where the directrix was 5 units above, the focal point is going to be 5 units below. And the coordinates of that point are 0, negative 5. So there's my focal point. Those are, okay, one other thing we could throw in here. What's the axis of symmetry? Remember, the axis of symmetry is a line that goes through the vertex and the focus. So that would be this line here. That's the y-axis. So the axis of symmetry would be x equals 0. And based on this information, I can sketch my parabola. It's going to go through this vertex. It's going to open down. It's going to look something like that. Now this one is a little more complicated. We have a y term here. We have a y squared and a y term. Right, so what I need to do is I need to fit this into one of my equations. It's going to need to look like y minus k squared equals 4a. And I know a is going to be positive. I know that part is going to be positive because this part in front of the x is positive. It's going to be 4a times x minus h. So how can I make that happen? Well, the first thing I'm going to do is I'm going to take that minus 4 and kick it over to the other side. So this is going to be y squared minus 4y. Now leave a space here. If you're following along, taking notes, leave a space here. This equals 8x plus 4. So it's this left-hand side that I need to turn into a perfect square. And the way we do that, we use a method, hopefully you've seen this before, it's called completing the square. So what I'm going to do is I'm going to take that negative 4, I'm going to divide it by 2 and square it. Right? If I do that, this is negative 2 squared. That's 4, so I'm going to add 4 to both sides of my equation. All right, so that turns the left side into a perfect square. This is now y minus 2 squared equals 8x plus 8. So we're getting there. right? The left side looks the way I need it to look. I still need to tinker with the right side a little bit. I need this x to have nothing in front of it, right? So fortunately, we got some nice numbers here. I'm going to factor out that number in front of the x. This becomes 8 times x plus 1. And great, now I know what the vertex is. The vertex, I can see what h and k are now. The vertex, and be sure you get them in the right order. The x-coordinate is coming off of this term, so the x-coordinate will be -1, and the y-coordinate is coming off of this term. That's going to be 2. So let's get that on our graph here. That is -1, 2. That's the vertex. All right, so how about the value of a? Right, that's really going to give me the remaining 2 key pieces of information. That's going to give me the directrix, and the focal point. Well, I'm going to take 4a, set that equal to 8, and that tells me that a is equal to 2. So my vertex and directrix are both, excuse me, my focal point and directrix are both 2 units away from that vertex. But in which direction? Well, we've got a y squared term here, so that's telling me that my parabola is going to open left or right. And because the a term, this part of the equation here, is positive, it's going to go to the right side. So that tells me the focal point has to be to the right of my vertex, and the directrix will be to the left of my vertex. So if I go 2 units to the right, I get this point here, right? That's the focal point. The focus is it's over 1 up 2. And my directrix is going to be a vertical line now, 2 units to the left. So that's this line right here. And that's going to be x equals 3. And finally, the axis of symmetry, that's the line going here through both of these points. And that is y equals 2. And that's all the information I can get from this, right? And if you like, you can also, you can sketch the graph in now. It's going to look something like this thing. So I've got one more example for us to look at here, and it's going to follow a pattern very similar to what we did in the last one. You notice we've got an x squared term, so that immediately tells me I've got either an upward opening parabola or a downward opening parabola. Okay, so I know that my equation needs to look like x minus h squared equals 4a times y minus k, and that is going to be a positive because the term in front of the y is positive. So, to start off with, I'm going to need to complete the square on that left-hand side. So this is going to be x squared minus 6x, and let's leave a space there, equals 3y plus 4. And what do I need to add? Remember our process for completing the square. I'm going to take that -6, divide it by 2, and square it. If I do that, I get 9. So that's the number that I need to add. Okay, so the left side is now a perfect square. This is x minus 3 squared equals 3y plus 13. All right, so this one is not going to be quite as nice over there on the right-hand side. So I need to get this y by itself. So whatever number is in front of the y, I don't care what it is, that's the number you're going to have to factor out of this thing. Right, so this is, I'm going to leave the left side alone. That's x minus 3 squared. And if we pull the 3 out, this is 3 times y plus 13 thirds. All right, so now I get my vertex. My vertex is at 3 comma negative 13 thirds. If you go over to my graph, that's over negative 13 thirds. That's a little past -4. So this will be -4 1/3. There's my vertex. All right, so my graph opens up, right, because I've got an x squared term, so I know it's up or down. This number is positive. That narrows it down to being an upward opening parabola. What's my value of a? Well, 4a has to equal 3, which means a is 3/4. Now, because this opens up, the directrix has to be below, and it's going to be 3/4 below. That's not a whole lot. So it's going to be pretty tight here. It's going to be right about here, maybe even a little higher up than that. Right? My art skills are pretty dubious. Right? So where is that? Well, this is the y coordinate here was negative 13 thirds. And we're going to get to this point, we're going to subtract 3/4 from that. So my directrix is y equals negative 13 thirds minus 3/4. You do a common denominator. That's what I'm doing this in my head now. That's negative 52 minus 9. So this is negative 61 negative 61 common denominator. Negative 61 twelfths, which is a little lower than negative 5. And yeah, that's where the blue side is more or less where I sketched that. Okay, so how about the focus? Well, the focus is 3/4 up from there. So this is going to be 3 comma negative 13 thirds plus 3/4. And we're going to have to do a common denominator. So this will be negative 52 plus 9, which is negative 43 twelfths. If we go over here to the graph, the focal point is 3/4 up from there. That's going to be right about there. And that's going to give us our parabola. So now I know it's going to look like this. And one more thing we do, if you want to throw the axis of symmetry in here, this one is much easier. No weird fractions. The axis of symmetry is passing through these 2 points right here, and that is just x equals 3. Now that we've seen how to use an equation to get information about a parabola, in the next lecture, we're going to go in the other direction. I'm going to give you information, for example, say the location of the vertex and the directrix, and we're going to see how you can take that information and turn it into the equation of a parabola that has those properties.